So that's a tough talk to follow. So I'm from Platform Computing, and this is just going to be a really short, less than 10 slides, with just a current update on just the tiny little bit of the slice of pie from Platform Computing that I'm in charge of. So very, very different mindset. So we'll get started just because I only have 15 minutes. So my focus is on bridging HPC to the cloud. And when I say cloud, I don't necessarily mean public cloud. I don't mean Amazon EC2, although that's certainly within the sphere of possibilities. What I'm really focused on is trying to take sort of the debate that we've almost had maybe 3 times in here since the beginning of the sessions, which is the HPC systems that we use today, whether they're capability systems on the very, very high end that many of you folks are familiar with, or the systems that I come from, which is probably not even considered HPC in many circles, be more like HTC, high performance technical computing, or high throughput computing even. Which of those is a cloud, and where are the differences? And I think we saw earlier that some of those differences, the things that make the HPC systems that we're using today not a cloud are very, very minor. So we see a handful of things that are blocking additional productivity that we can get with our HPC systems today. One of them is rigidity. And I say rigidity because at the middle or the bottom of the pyramid in HPC, more and more applications are being piled into an HPC system. You need to run design applications. You may need to run financial analysis applications. You may even need to do fund management for your company. And who knows? Maybe other things for finance or for market research. Because of that, and especially because of many organizations are global today, we end up with various types of inefficiency, whether that's following the sun inefficiency or others. And then finally, certainly our resources are finite, and therefore we can bump up against an incapacity problem. Eventually, you run out of what you have, and you need some more to be able to do more. So this is sort of the evolutionary path that Platform has spoken about for quite some time, where we start off with, with clusters and grids, and then we start, and that's where we are, roughly today. We're around here, where people have been using clusters and grids for quite some time, and now we start bridging. We start bridging this gap of, well, are we a cloud or aren't we, when we start talking about private cloud. And those are the things that I'm really focused on. Well, maybe we can derive some additional productivity by using what you have better. And that's the software that Platform's putting forward today, or that I'm going to talk about today. So static infrastructure and our traditional one operating system cluster, or one type of application cluster even, it forces us to make some trade-offs. And those trade-offs are things like when you have additional disciplines or others asking you I want you to be able to process this in your HPC environment as well. You either have to say, I have to build a separate environment, or I have to add it and figure out some way of being able to arbitrate between the different disciplines. And that happens not just between 2, not just between 3. So, and you end up having to make this compromise of, you end up having static HPC capacity and you get fantastic utilization, or you end up smearing across an HPC environment a number of different capabilities, and you end up with much lower utilization but a lot higher service level, because you can service a lot more customers with diverse requirements. Well, we'd like to be able to do this up here. Give you great service as well as great utilization, and the only way to do that is to be able to have things adapt over time. take the place where platform sits. We sit between the user and their requirements and the infrastructure. But the thing that we've never done before is make that infrastructure reflect the requirements right now. And tomorrow, when those requirements are different, do it again. And it may be completely different. And that's really the unique thing. And the product that I'm going to talk about for the rest of this talk is a product that we've just recently released called Adaptive Cluster. Obvious name. So what we're trying to do, whoops, sorry, buttons are backwards from what I'm used to. Turning a static cluster into a fully dynamic private cloud environment. If you want to call it a dynamic grid, I don't care. We can use the buzzword cloud anytime you like. So let's reduce some of the complexity of that user environment, so that every user, doesn't matter their discipline, is interacting with the system the same way. Let's allow them to benefit from all the expertise that we've built up over the last 20, 30, 40 years doing HPC, so that they can go on with doing their science or doing their simulation or doing whatever it is that they need to do to derive value and forget about all the computer science that's happening in the background. Of course, we're gonna want to reduce cost, and that comes in a number of different ways, but also by pumping up our utilization with these diverse requirements. We're saving power. We're being green. And finally, let's automate this administration so that even an administrator doesn't have to worry about how many of how many sets of Red Hat 5.2 does he have, and how many virtual machines is he running, and how much saturation has he reached on either his network or his shared file system. Let's have it so that he can set up a policy to govern these things, because he understands where things cross a red line for all these different parameters, and make sure we never go there. So these are just a few. These are just a few use cases of what Adaptive Cluster can do today. So as I said, we're talking about environments that are heterogeneous, multiple disciplines, multiple requirements, not just single application. It's all kinds of different applications. And in those kinds of environments, whether you're talking about folks doing current design as well as doing legacy product support or what have you, you end up in a heterogeneous environment from the point of view of many different standpoints, whether it's virtual machines versus physical, whether it's Windows versus Linux, whether it's one version of Linux versus another, or even a subversion. So in this case, I just used Red Hat 4.8 and Red Hat 5.5. But you can imagine in the simplest case, you have a workload. See, with the orange dots there, that is out of balance from the way you've provisioned your infrastructure. I have a lot of Red Hat 4.8 workload right now, and not very much Red Hat 5.5, but 4 out of my 6 machines are Red Hat 5.5. I'm going to end up with idle machines and pending jobs. That's not good for anybody. With Adaptive Cluster, we can actually dynamically reprovision the infrastructure so that it reflects the workload right now. That's just one thing it can do. Another thing that we can do, well, we've talked about cloud computing and referred to the only way to really get cloud computing to be adopted for the HPC community is by recognizing that, yes, sometimes virtual machines are very, very handy, sometimes they're not. And when they're not, they can be really bad in terms of performance. Well, okay, so in the cases where they are handy, what can we do? Well, this is another situation that can happen, and it happens all the time at our major customers in EDA. You end up with a large memory job sitting in the pending queue, while you have other jobs that are consuming various amounts of resources checkerboarded all throughout the system. As an aggregate, there's plenty of memory out there to run this job. The problem is that no individual server can actually do it. Well, if there are a handful of jobs out there that are running in virtual machines because the impact to them is nominal, then move them and get that job going. Higher utilization, better service to your users. So, just a case study. I'm not allowed to mention the name of the customer. They're very secretive. But this customer had service level requirements for high priority workloads that up until this product was released, they would have to reserve their infrastructure just for this set of priority workload. Okay, it certainly allows them to deliver the service level that they needed to for that group. However, when that group didn't have any workload, those machines sat there idle, and they're expensive because they're big memory machines. So what are the alternatives? Well, they could have allowed lower priority workload to run on those reserved machines, but then when the high priority stuff comes, it has to wait, or they have to suspend or kill it. Well, kill workload, you're throwing even more energy away. And if you suspend it, well, there's actually some overhead associated with suspension. One, it takes time. Two, you're waiting for the operating system to page dirty memory out to disk. A number of things which were simply not acceptable. Also, you're depending on those jobs to being able to come back cleanly once they're resumed after the high priority workload is finished. That can work okay sometimes. In other cases, and very, very often in a commercial environment where you're using licensed software, FlexLM does not like to come back after a suspension. So finally, we released this product essentially specifically for them initially, and it allowed them to use reserved infrastructure for low priority workload, but when the priority workload lands, it doesn't suspend anything. We migrate those jobs because the low priority workload nominally doesn't get very impacted by virtual machines. So we can push that out of the way and let the high priority workload run on the physical OS, get the highest performance that it possibly can, and not run afoul of any jobs being killed, losing all kinds of power, losing all kinds of cooling, and deliver the service both to the high priority workload and additional throughput to the low priority workload. That's it. Any questions? Yeah.
Chris, just curious, you mentioned several parameters on which adaptive cluster would rearrange OS, memory, priority. Are there other parameters or even user-defined parameters that it could be adaptive on?
Certainly, yes. There are a number of things that we can do because we interface with a number of physical provisioning engines. Not only can you reprovision an arbitrary operating system, but you can also retarget systems from physical operating systems to hypervisors. So if you needed either additional physical OSs for jobs that require a higher performance and you need a physical OS, you can do that, or you can go the other way. That's one way. Also, there's a very, very rich set of policies built into adaptive clusters so that the administrator can decide when any of these actions take place. And that's a detailed conversation we can have separately. Yes?
Chris, in addition to that, the notion of active power management and draw on the servers.
Yep.
Are you doing anything there? Some of the Intel technologies, Node Manager, things
Absolutely.
like that?
So the first thing that we're doing is there are background policies that can be enabled or disabled. So as I said, for the workload that is running in virtual machines, it's mobile. It's no longer tied to the hardware. When you have a mobile workload, and you have some view of what's going on in your network and your shared file system, you can make some decisions about, under these conditions, I can pack my workload. When I pack my workload that's mobile, then I can maximize the number of machines that are idle, and then I have all kinds of opportunities with respect to power. I can start telling those machines to start stepping back their power more than what they would do automatically. You can suspend them entirely, and you can also maximize the chances of, if I end up with a big chunk of workload that requires a full machine, I'll be able to launch it immediately rather than have to do that. Essentially, you're doing things proactively rather than reactively. So you end up providing a higher level of service. Great. Thanks a lot.
Thank you very much, Chris.